morning. Good morning. Good morning.
What is upscaling? When we upscale an image, we are essentially re-estimating the values of newly added pixels on a denser, larger pixel grid than the original image. The simplest solution is to use traditional upscaling algorithms, which is usually done through deterministic mathematical resampling. Nearest exact is the hardest but also the roughest. Bilinear is fast but easy to become blurry. Area is more suitable for downscaling. Bicuxic is a relatively balanced traditional solution, and Langsons is often the sharpest, but also more likely to cause edge halos. A slightly more complex solution is to use neural network-based AI super-resolution models. These models use a large amount of image patterns learned during training to reconstruct and enhance edges, textures, and structures. For example, the sharper-styled 4x ultra-sharp can often bring a strong sense of clarity. The more stable and universal real ES Rajan is often used as the default for real photos and complex scenes. Models like Anime Sharp and Aniscale are more oriented towards specific materials such as anime, illustrations, and line drawings. OpenModelDB collects a large number of such models, and you can search and try them according to your image type and target style. A further approach is to use generative models. You can directly use image generation models to redraw the original image at lower denoising intensity. You can also use generative models specifically trained for image or video super resolution and restoration tasks, such as SeedVR2 and FlashVSR. The advantage of these methods is that they can fill in stronger subjective details and richer textures, especially suitable for scenarios with severe blur, obvious compression artifacts, or content that needs to be completed. But the trade-off is that the results are not necessarily completely faithful to the original image. A video is a series of consecutive images. When upscaling, besides needing to upscale each frame individually, you also need to additionally handle the temporal consistency between frames. In other words, image upscaling mainly cares about single frame clarity, while video upscaling, in addition to clarity, also cares about whether flickering, drifting, and details are stable throughout. After understanding these approaches, let us look at today's main character, RTX VSR. It is essentially a neural network-based AI super-resolution and enhancement technology, more oriented toward improving clarity and edge performance at near real-time speed in video scenarios. RTX VSR is not a new technology. NVIDIA launched it in early 2023, mainly targeting low-resolution videos in browsers and local players, using RTX graphics card tensor cores for real-time enhancement and upscaling. Later, NVIDIA also released this capability in the form of a developer tool called RTX Video SDK, making it convenient for third parties to integrate it into their own software and workflows. Recently, it has returned to our attention because ComfyUI created a ComfyUI plugin called ComfyUI NVIDIA RTX nodes based on this capability, depending on NVIDIA DV effects, making it easy to use for image and video upscaling in ComfyUI workflows. Before we officially start, let me clarify the positioning. RTX VSR is more oriented toward upscaling plus clarity enhancement. It can make edges sharper and reduce compression artifacts, improving subjective visual perception. If you hope to actively generate a large amount of new details, you need to use a diffusion model solution, such as switching to SeedVR2 or LTX2.3 upscaler, which will be compared later in this video. Its three biggest advantages are: first, it is very fast. On a 5080 graphics card, upscaling a 5-second 1080p video to double size only takes about 10 seconds. Second, it has low VRAM pressure. You do not need to load an entire large model into VRAM. Third, it requires almost zero model downloading, with very low learning curve. Of course, it also has limitations. Hardware-wise, it requires NVIDIA RTX 20 series and above consumer-grade graphics cards. Data center cards like A100 do not have good support, and the driver version cannot be too old. The installation process is a bit of a hassle. Installing directly through Manager will most likely fail, requiring manual handling. The official plugin only supports upscaling. If you want features like DENOISE and DEBLUR, you need to install the community-modified PR27 version plugin. Additionally, there are sometimes errors during operation. In this video, we will start by demonstrating the installation of RTX VSR plugins, including the official and modified versions. Then we will explain its 4 working modes. Finally, we will compare the effects of SeedVR2, FlashVSR, Wan2.2, and LTX2.3 upscaler, analyzing which scenarios each is suitable for. Alright, without further delay, let us get started. Start ComfyUI. I am currently using version 0.19.1. By the way, recent versions of ComfyUI after roughly 0.6 have some issues with VRAM or memory management. Many workflows that used to run normally now get OM. Wait patiently for the fix. If you are in a hurry, you can try rolling back to an earlier version. Open ComfyUI Manager and search for NVIDIA RTX nodes. Find the ComfyUI NVIDIA RTX nodes with author comfy.org and click Install. The download is very smooth. Now you need to restart ComfyUI to complete the installation. After restart, we can check if the installation was successful through Manager. However, a simpler method is to check ComfyUI's startup log. Scroll up a bit and it will display all imported plugins. As expected, it failed to load. If you are interested, you can continue scrolling up to see the specific reason. However, I know it is a dependency library issue, so I will go directly to fix it. Close ComfyUI, start PowerShell in the root directory, and enter this command to install NVIDIA DFFX using ComfyUI's Python environment. It completes easily. Start ComfyUI again and check the plugin loading status. This time there are absolutely no problems. Using the RTX VSR plugin is very simple. Let us create a new blank workflow. Double-click and enter RTX in the pop-up window. Nothing comes up. Why is that? Because we manually restarted ComfyUI just now. The front-end did not get the latest data. Refresh and search again. Add the RTX VSR core node. The entire node is very simple. Input is image or video, which is multiple images. Output is the upscaled images, and there are very few parameters. First is the upscaling type. The default is multiplier upscaling. The multiplier here refers to the edge length multiplier. For example, if set to 2, both the width and height of the output image will become 2 times the original, so the total area will become 4 times the original. This multiplier can be adjusted from 1 to 4. Note that the node will automatically align the output size to a multiple of 8. Another upscaling type is to specify the target size. You can directly fill in the target width and height, ranging from 64 to 8192. The last parameter is quality, with options low, medium, high, and ultra. Higher quality usually means higher VRAM usage and slower speed. However, this plugin internally limits the maximum processing pixels per batch to 16M and will automatically adjust the batch size to control usage. In actual use, I usually directly use ultra. Upload a STEN24x24 portrait image as the node input and connect an image save node as the output. Click Run. It is amazingly fast, completing the upscaling in just 0.88 seconds. The result looks fine. Let me add an image comparison node to take a closer look. It completely respects the original image without being over-redrawn or content tampered with. After upscaling, the model's eyes, lip shape, and even the degree of blush on cheeks are exactly the same as the original. The detail improvement is mainly concentrated on texture and edge layers. For example, each strand of hair becomes distinct, embroidered patterns become clearer, and the lighting transitions of fabric folds become more delicate and natural. The most intuitive is the eyes. Pupil texture and eye highlights are significantly enhanced. Now try video upscaling. Let us use this dancing pajamas kitten video generated by LTX2.3. The size is 1280 by 704, a total of 18 seconds and 433 frames. Let us upscale it 2x through the plugin and recombine it into a video. Click Run. It only took 7.96 seconds to complete the upscaling. Keep in mind that combining so many image frames into a video took more than 32 seconds. Look at the result. It is a 2560 by 1408 2K video. Play it. The most obvious feeling is that there is absolutely no flickering. Take a single frame for comparison. Look at the pattern on the blue cat's clothes. The contours become sharp and clear, and the color saturation is also moderately enhanced. It is no longer a mess of blurry color blocks. Although RTX VSR supports various upscaling options, the official RTX VSR plugin is just that simple. If you want to use more upscaling modes, there is a PR version in the GitHub repository. This PR has been submitted for a while and has not yet been merged by the official team. Generally, using the PR version requires using git commands to switch in the plugin directory. However, since this PR actually only modifies one file named init.bi, a simpler solution is to directly go to the plugin directory, back up the original file, and then download the PR version file to overwrite it. If the plugin is updated later, we can restore the file, or simply delete and reinstall the plugin. Restart ComfyUI and refresh the page. You can see that an upscale type option has been added to the plugin nodes. There are 4 different options: UPSCALE, DENOISE, DEBLUR, and HIGHBITRATE. They correspond to different quality level in NVIDIA DVU FX. Upscaling is the option already implemented by the official plugin. Let us continue using the image I demonstrated just now. Click Run, and you will get the same result as before. Another option that also supports upscaling input content is HIGHBITRATE. Let me copy a node here to run it, and add an image comparison node to see the difference. It took less than 1 second to get the result. Comparing the results of these 2 different modes, there is almost no obvious difference. I stared at it for a long time, and maybe only the brightness of the eyeballs has a tiny difference. However, this kind of visual observation is not rigorous enough. We can verify it with a more professional method. Upload these 2 images in a blank workflow, add an image blend node, change the mode to difference, and set the strength to 1. This gives us the difference map of the 2 images first, but looking at it directly, the difference is still difficult to observe with the naked eye. So let us add a built-in image level subgraph node in ComfyUI to further amplify these subtle differences. After clicking Run, the result is basically a black image. This shows that the 2 images are actually very close overall, with little difference. We raised the gamma to make those originally very dark and inconspicuous differences easier to see. After running again, the result is much more obvious now. You can see that these 2 algorithms have differences in most areas of the entire image, but these differences are relatively minor. For this particular image, the final visual impact is not particularly large. According to NVIDIA's official statement, HIGHBITRATE is designed for high-quality, low-compression artifact materials for detail enhancement. In most cases, you can directly use UPSCALE. Let us look at the DENOISE mode. Note that its scale can only be set to 1, otherwise it will report an error. Let us upload this night scene image with obvious noise for testing. Click Run. The denoising effect is immediate. The sky becomes smooth and clean instantly, and dense granular noise is effectively removed. At the same time, the contours of streetlights and distant buildings are not made blurry by denoising. However, you should understand that the core logic of this mode is purification rather than enhancement, so it will not add details to parts that were already blurry in the original image. Finally, let me demonstrate the DEBLUR effect. This time I will upload a video. You may all have seen this video. It is the original version of the famous nice meme. The face contours and facial features are clearly distinguishable without structural distortion, but the overall sharpness is insufficient. Let me add nodes to the workflow for getting video information, combining videos, and comparing effects. Click Run. This video is relatively small and only took less than 1 second to process. Check the result. It removed the feeling of the original image having a thin veil over it. Contour sharpness is restored. The granular texture of beard stubble, fine wrinkles around the eyes, and skin texture are effectively pulled back. The lighting levels are cleaner. To summarize, these 4 modes are each suitable for different scenarios and all have obvious advantages. Video upscaling is the core of this tutorial. I will use RTX VSR's UPSCALE mode as a baseline to horizontally compare several mainstream solutions, focusing on effects, time consumption, and VRAM usage. The test material is a turning video generated by Wan2.2 with 480 by 832 resolution and a total of 81 frames. Before LTX2 series supported direct 1080p output, this kind of 480p or 720p was exactly the standard quality for local open-source models. Adjust the node parameters, select UPSCALE, and set the multiplier to 2. Click Run. It only took 1.23 seconds to get the result. Like the static image just now, at first glance the visual change is not obvious, but the resolution has objectively doubled to 960 by 64. Even pulling the multiplier to 4, on this machine it only takes 1.83 seconds to output a 120 by 328 ultra-high definition video. In my view, RTX VSR's advantages are obvious: fast, extremely low VRAM usage, and more importantly, its processing logic is very restrained. Whatever is in the original video, it restores exactly that, never adds anything extra, does not produce temporal flickering or weird AI artifacts, and has very good overall stability. But being restrained is also its shortcoming. Because it does not improvise or redraw, you do not get that amazing feeling of details suddenly increasing. If what you pursue is a qualitative change in image quality, then you should go with a generative AI solution. For example, SeedVR2, which I use most often recently. Let us directly import this workflow, load the same input video, and continue testing. Set the resolution to 960 to get an output with the same size as RTX VSR for comparison. Regarding the specific workflow construction, I have already covered it in detail in my previous video, so I will focus on parameters related to reducing VRAM usage. First is model selection. SeedVR2 has many models in different formats. Here I choose the FP16 Precision 7B version, which theoretically has the best results, but also has the highest VRAM requirements relatively, is slower, and is harder to run. If you have trouble running it, can use the 3B model, or choose FP8, GGUF and other quantized formats. Blocks to swap is the most critical parameter. The larger the value, the more VRAM you save at the cost of slower speed. My default is 32. If you get OOM, increase it to 36. Offload device should always choose CPU, which can unload temporarily unused content from VRAM to memory. Various tiled parameters should all be set to true, which allows tiled execution of encoding and decoding. The smaller the tiled related size, the more VRAM you save, but also the slower it becomes. It is best not to change overlap size, as it affects stitching effects. Batched size is the number of frames processed per batch. If VRAM is insufficient, you can lower it to 21 or even 17. Click Run. It took a total of 157 seconds. Compared with RTX VSR's restraint, SeedVR2 does bring a visible explosion of details. For example, the blurry halo of original hair, the texture on the dress, and changes in human skin and facial features have all been significantly reshaped. Overall color saturation and lighting atmosphere are also more transparent and cinematic. But this also causes some changes different from the original video. For example, facial features have some differences, especially obvious here at the left eye. Complex textures like hair may flicker during movement. Moreover, the cost of image quality leap is also very realistic. VRAM requirements are far higher than RTX VSR. It is difficult to run 4x upscaling with this workflow. Low-end graphics cards can easily get OOM. The speed gap is enormous. You often need to run for a few minutes or even tens of minutes. However, as long as time and hardware resources allow, it is still my preferred solution for video upscaling. FlashVSR is another generative video upscaling solution. The flash in its name indicates its biggest advantage: fast. Load the workflow and the same material. Since FlashVSR thinks it is best at 4x upscaling, we first reduce the video to half of the original, then sample and upscale 4x, ultimately achieving a 2x effect. As we mentioned in the first part of the video, it is best to use the area algorithm for downscaling. When determining the target size, FlashVSR has fewer parameters to reduce VRAM usage compared to SeedVR2. The main ones include: enable offload and full tiled, use lightweight VAE, enable tiny long mode. Additionally, lowering local range usually has some effect. Click Run. It took about 20 seconds to get the result. Compared with SeedVR2, FlashVSR also reconstructs and increases details based on guesses from the input, but overall it respects the original video structure more, emphasizing local fidelity and sharpening textures more cleanly and naturally. Therefore, in videos with more motion and dynamic shots, its temporal consistency and smoothness usually perform better, with lower possibility of flickering and jittering. At the same time, FlashVSR's processing speed is much faster than SeedVR2. In the quality-speed trade-off, it can be considered a choice between RTX VSR and SeedVR2. There is another popular video upscaling solution. First, use an image upscaling model to increase the size, then hand it to a video generation model, and use low denoising intensity for redrawing to fill in details. For example, here we load a workflow based on the Wan2.2 model. Wan2.2 is divided into high noise and low noise models. The high noise version is responsible for motion planning and overall composition, while the low noise version specializes in detail supplementation and image quality optimization. Here we only need to use the low noise model and load the LTX2.3 acceleration LoRa. The specific process is, first split the video into frames, upscale 4x using 4x ultrasharp, then downsample to half using the area algorithm, 1 in, 1 out, resulting in a net 2x upscaling. But pure image upscaling does not have a concept of timeline and lacks context information between frames, making it extremely prone to flickering or jittering. Therefore, it must be handed over to the video model for adjustment. The denoise strength is set to 0.2. This value can add a lot of details while not completely changing the original picture. Leave the positive prompt empty and only run 4 steps. It took about 6 minutes. The video quality can be considered the best so far. Each strand of hair is not only distinct, but also has natural light reflection flow. Lace patterns, skin texture, and background flowers are all finely reshaped, with overall texture directly maximized to cinema level. However, it is also the most different from the original video. Facial features and expressions are clearly different. If you are pursuing image quality enhancement, it is difficult to accept this kind of complete transformation. Even lowering the denoise strength to 0.1 and steps to 2, it is still difficult to maintain consistency with the original video. As far as our material is concerned, using the first frame image for image to video should help, but this cannot be used as a general solution. Wan2.2 is still too heavy, with high VRAM requirements and slow running speed. Let us switch to LTX2.3 to try. Load the video upscaling workflow provided by the LTX official. Use the LTX2.3 FP8 version for the model, load the detail enhancement LoRa, and in the pre-testing stage use the Lanczos algorithm to pull the long edge to 16664 pixels. This way the final output resolution is exactly the same as before, facilitating horizontal comparison. LTX2.3's VRAM requirements are relatively low. Running with default parameters is very stable. If you still encounter OOM, you can first try reducing temporal tile size, spatial overlap, and temporal overlap, or switch to the GGUF quantized version of the main model. After clicking Run, it took less than 50 seconds to get this result. Overall, the image quality is already quite high, but the fidelity is far higher than the redrawing approach, and temporal stability is first tier. This is a balanced solution. The disadvantage of LTX 2.3 is poor performance during large movements or complex deformations. However, you can use the same workflow and switch to the LTX2 model, which will give better results. That concludes the demonstration part. Let me summarize. RTX VSR is an efficient and stable upscaling solution. Fast speed, low VRAM requirements, and low learning curve. After installing the PR27 version, in addition to the default UPSCALE mode, you can also use HIGHBITRATE, DENOISE, and DEBLUR modes. Its core shortcoming is that it stays true to the original footage, and detail enhancement is very restrained, which often gives people the illusion that it looks like nothing changed, even though the video was clearly upscaled. Additionally, in this video we horizontally compared 5 video upscaling solutions. A quick summary. RTX VSR has fast speed and low requirements, suitable for time-sensitive situations, limited hardware, or scenarios where fidelity is the priority. SeedVR2 can bring visible detail reconstruction with cinema-level improvements in color and lighting, but rendering is slow and VRAM requirements are high, with dynamic textures possibly flickering, suitable for creative short films pursuing extreme image quality without regard to time and hardware. FlashVSR has better temporal consistency, natural and restrained detail enhancement, and is much faster than SeedVR2, suitable for videos with many dynamic shots that need to balance efficiency and image quality. Wan2.2 redrawing is the ceiling of image quality, with cinema-level human skin and all kinds of details, but rendering is very slow, VRAM requirements are the highest, and the difference from the original footage is the greatest. suitable for promotional materials and scenarios that can accept complete transformation. LTX 2.3 has moderate speed, moderate VRAM, good image quality, fidelity far higher than the redrawing approach, and first-tier temporal stability. It is currently the most balanced universal solution. Alright, that's it for today's video. If you found this content helpful, please give it a like to support. All model and workflow resource links mentioned in the video are in the description. Feel free to grab what you need. See you in the next video.